All right, so we're going to get into a superposition review. Hopefully those of you who took 220, this is very straightforward. So I'm just going to rush through it pretty quick. Superposition typically used, actually exclusively used for circuits that have more than one source. So step one is to remove all but one source from the circuit. And by removing sources, just recall that if I want to get rid of a voltage source, I replace it with a short. And if I want to get rid of a current source, I replace it with an open. Okay, just recall that. So we solved the circuit then for the node voltage or current slash voltages or currents of interest. Then we do this for each source in the circuit, and then we sum the results, and that gives us our final answer, right? So let's go ahead and set up an AC superposition problem here. Let's go, I'm going to use a sinusoidal source here of basically V, let's just call it Vs1 of t, and I'll just make it a 1 volt sine wave, so I can just say sine of omega t volts. And then over here, let's put an inductor, a resistor, and then let's go with another inductor. All right, and then right here we'll go with another sine wave, and we'll make this one Vs2 of t, and I'll make this one 3 times the sine of omega t volts, and let's just let omega equal 2 pi times 1 meg. So I'm basically operating at 1 megahertz, okay? All right, so that's my omega for this circuit. Let's let my L1 equal 10 microhenries, my L2 equal 30 microhenries, and let's let my R be 25 ohms. All right, so that's my circuit, and I am interested in determining V, let's just call it Vx right here, Vx of t, that's what I'm interested in. And so this, of course, is my Vs1 of t, this is my Vs2 of t, and I want to find Vx of t, okay? So how would we solve this circuit using superposition? Well, it might help to convert everything over to the phasor domain first. So let's go ahead and start by doing that. If I were to draw this circuit in the phasor domain, I would obviously have a couple of impedances, just like this. All right, and then I can write my sources as phasors. So this one I can just write as 3 angle 0. This one I can write as 1 angle 0. Correct? I made the numbers nice and easy so that I can do it really fast here. So for the first inductor, ZL1 I guess we would call it, that's going to be J times omega, which is 2 pi times 1 megahertz, times L. So the 1 meg and the micro cancel, so I just get 20 pi there, J 20 pi, okay? And then for L2, it's going to be basically triple that, so it's just going to be J times 60 pi. Hopefully you see how I'm doing that. I'm basically just saying that my Z for my inductor is equal to J omega L. I know my omega is 2 pi times 1 megahertz, and this megahertz and the microhenries cancel, and I'm just left with basically very simple mental math, okay? So I'll just write that right there just to keep it there. And then, of course, the impedance of my resistor is just the resistance, so it's still just 25 ohms. Okay, and I'm interested in finding Vx of t. And so what we're going to have to do for superposition is we're going to have to solve the circuit with the first source in there, and then solve the circuit with the second source in there, and then sum what we get for the two, okay? So I think this video's probably gotten a little bit long, but the problem's all set up now. So in the next video, I'll solve the circuit. I'll basically just start to go through the superposition process, and we'll get to an answer eventually. So I'm going to go ahead and end this video here.